Take your seats. Sorry for the abrupt change-up, but we are really excited for you all to be here today. Welcome. Thank you for joining us for the Solution Provider Showcase, Byproducts to Brilliance, basically transforming food waste into, I would say, value. My name is Alejandro, and I will be your host for this session, along with my co-host, Nia at the back. Nia, say hi. Nia's at the back in orange. So this is the first time we've ever hosted a Solution Provider Showcase at our annual summit, and our goal is to share with you all the promising food waste solutions that are out there. And then also allow the audience and the judges to really dig in and ask the hard questions. So today we'll be hearing from 3 food waste solutions. Time's a little tight, so sorry about that, that transform otherwise wasted product into valuable materials and products that solve challenges in other industries. After each presentation, there will be about roughly 8 minutes of Q&A by our gracious judges that are going to be sitting up here at the front. They're kind of in the audience as well. And so with us today, I would like to introduce you to our judges. First is going to be Jen Burka. Jen, wave. Hello, everybody. Hello, Jen. Jen is an investor at FTW Ventures, where she focused on opportunities related to climate solutions, sustainable packaging, and innovation in health and wellness. Prior to joining FTW, she was a senior associate at Evolve Ventures. That's Kraft Heinz's $100 million corporate venture arm. And there she was also focused on food tech, sustainability, and packaging. Next is we've got Brad Crapeau, the founding partner and CEO of Food Cycle Science, and I would say like a fellow entrepreneur. He has transformed the company from a local startup into a global leader in sustainable food waste management, having sold products in over 20 countries with a diverse team of nearly 50 dedicated professionals. Food Cycle Science continues to disrupt traditional food waste management practices and make a positive impact on the world. So let's give him a round of applause. And so basically, what is going to happen is, and I'm going to just click through the slides pretty quick. Basically, like once we've heard from all the presenters, we will open the floor to questions at the end of the session. So how the format's going to be is that they will present for roughly 5 minutes. The judges here will ask a few questions. They'll roughly span about 8 minutes. And then we'll go through 3 presentations. At the end, we will have it open for the audience to ask questions of these founders. And so basically what will happen is the judges will then announce the winning solution based on a set of criteria that we've provided them. But basically it's understanding the problem that they're trying to solve, the solution's unique competitive advantage, its ability to be replicated or scaled, and its environmental and social impacts. And I should note that this is not a pitch competition, although it feels like a pitch competition. There is no prize money, but there is pride, I guess. And of all the solutions that you're going to be hearing today, we love all of them. They're all incredible. So this is really a showcase, but you know, the nature of this is we will pick a winner. And so without further ado, I would love to welcome our first presenter, Andrew Majar, the co-founder and CTO of Capra Biosciences and the co-inventor of Capra Biosciences biofilm reactor technology. Andrew has over 20 years of R&D experience in biotechnology and advanced materials. He holds a PhD in materials science from MIT. And also apparently he has studied cuttlefish and how they change colors. And so without further ado, let's give a big round of applause for Andrew.
Hi, everybody. I'm really excited to be here today at my very first ReFed Summit. You know, the reason that I am here is because this organization is really looking at solutions for food waste. What the biomanufacturing industry today really needs is a solution for the carbon we're going to use to make materials of the future. And so we are really looking at how we can use the right types of food waste with our technology, and I'll talk to you a little bit about that today. So I'm the co-founder and CTO of Capra Biosciences. I started the company back in 2020 with our CEO, Elizabeth Onderko. We came out of the Naval Research Lab. And I'll start with just a really quick anecdote. So Capra Biosciences, Capra is the Latin word for goat. I have my little goat pin here. You can see our logo is a little goat. And so we're really inspired by goats because they eat junk. Like they'll eat poison ivy and clear a whole field. They'll get into stuff you probably don't want them to. But at the end of the day, they're also able to make things like goat's milk, which you can turn into goat's cheese, and all of these, like you can make candles and cosmetic products, all of these amazing things using products from goats. And this is enabled by microorganisms in the gut of the goat. And so our bioreactor is sort of like these gut organisms in the goat, and that's really our inspiration. So with no further ado, let me talk to you about the problem that we're really trying to solve. So today, the biomanufacturing industry needs an awful lot of carbon if they're trying to really replace all of the petrochemicals. So most biomanufacturing companies are really focused on feedstocks like refined sugars. And so there's only about 100 million metric tons of sugar produced globally, and most of that is going into food. And if you look at the size of the petrochemical industry, it's close to 650 million metric tons. And so if we're really starting to think like, okay, well, where are we going to get this carbon from? Well, we could plant more sugarcane, but sugarcane is already a big cause of deforestation. It's causing fertilizer to end up in the coral reefs off Australia. There's all sorts of really negative impacts. Food waste is something that can be on the right scale, and if we choose the right food waste, we're not interfering with the food system. But to be able to do this, we really need some innovations in bioreactor technology, and that's what we're focused on at Capra. And so, do I have to press again to play the video? Okay. So this is a video of our lab-scale bioreactor. So it's this columnar system where we basically grow a microorganism, and it can eat a really wide range of different types of food. So that could be food waste, it could be agricultural byproducts, it could be glycerol that's coming from biodiesel production. And we circulate it through this reactor where we're able to extract the product right in the system using organic solvents. And so this could be traditional organic solvents, or it could be something like a vegetable oil. And then right on that system, we filter out all of the stuff we don't want from that organic solvent and end up with a pretty pure product. And because of how this bioreactor is designed, we are able to achieve economics that are much more tractable for biomanufacturing. So our thesis is really very similar to one of the sessions I was just in, where people were talking about like consumers are never going to pay a price premium for sustainability, and this is something we've seen. So our very first product is retinol, and so we've talked to cosmetics companies that, you know, they're paying pennies for the retinol that's going into a product, but they're not interested in paying any price premium for sustainability. So our technology has a number of different advantages over current fermentation technologies. The modularity allows us to deploy more easily at a source, so we don't have to have a giant facility to be cost competitive. We can have a small modular facility. And this allows us to really scale to meet particular product need. And by tackling both the problem of food waste and the problem of petrochemical production, we really have a fairly large impact potential. So as we scale into bigger and bigger, more commoditized markets like lubricants or chemical intermediates, we estimate that we can achieve eventually about a 1.3 gigaton per year CO2 equivalent emissions reduction if we get to be sort of, a BASF sized company someday. So what we're looking for here is we're really looking for partners. So if you are with a big or small company that is producing food waste and you're looking for different ways to maybe valorize that food waste that a lot of the other organizations can't take to feed people, please reach out to me. We're also interested in people in the chemical industry or personal care industry that are looking for sustainable products. Thank you very much.
Going to our judges for some Q&A. We're shifting to 6 minutes instead of 8. So judges
Will you let us know when we?
I will.
Okay. Really, thank you so much for the presentation. I love the goat anecdote, so thank you for that. So my first question is, could you just talk a little bit about the competitive market and who you're competing with in this space and how you're differentiating yourself?
Yeah, thanks. So you know, my thinking on this has changed a lot. So when I was asked this question 6 months to a year ago, I was always naming a list of synthetic biology, biotech startups. And I think that there's enough open space for all of these peer companies right now. And so I really think that the competitors are these large legacy companies, your BASFs, your DSMs, Evonik, like these companies that are making these products today from petroleum are the companies that we really need to be disrupting. There's enough opportunity in this space that all of the companies that are like Capra, like Checker Spot is a great company that's making bio-based oils and turning it into really cool products. There's a number of different companies in this space. I think each of us have our own unique niche, and so I think that really it's the people that are making the products on the market today that's the competitor.
Andrew, congratulations. It's really innovative stuff here and inspiring to see what you've built. I'm curious, if you were to go into a customer pitch, how would you describe their ROI profile? Is it, whether in dollars or in time, what's that look like, that profile?
So for customers.
Yes,
yeah,
correct.
so our customers are going to be the chemical companies. So we're actually, this is something I didn't mention that I meant to. So when we're doing our economic analyses, we always put a price on feedstock. So we're anticipating whoever we're getting our feedstock from, we're going to be paying for that. We're not counting on tipping fees. That's not part of our business model. So for our customers, it's a product that they can have a more reliable supply chain. It has lower carbon emissions, and in some cases, just a unique story.
Maybe just to follow up on that, because it's close to my heart, but the food waste component, could you talk to me a little bit about the logistics of how that comes into you, and whether or not the variability of food waste has an impact on what you're doing? If you're taking it from, you know, a fresh food grocery store versus a Chinese restaurant, does that have an impact?
Yeah,
And sorry, and related to that, just so we can add it together, is there any sort of pre-processing that has to be done to that food waste before you use it?
so that is very dependent on the type of food waste. So for example, we're starting with brewery waste, which we can basically put right into our process. We're actually now testing some fish waste, which we believe we can also put straight into our process. Because our organism actually doesn't eat sugar, if it's a high sugar content waste, we actually do a process called arrested anaerobic digestion, which converts it into basically biohydrogen and fatty acids first. You know, with the modularity of our technology, we wouldn't anticipate that a particular set of reactors would be switching feedstock a lot. We would be, like, you know, partnering more with, I don't know, but we'll even go with a Chinese restaurant. Like night to night, the Chinese restaurant is probably going to be pretty consistent. So we'll optimize that set of reactors for that carbon input.
And when you're calculating sort of your unit economics and the costs, are you assuming that you're going to have to pay for that waste, they're going to pay you to take it, or it's at zero cost?
Yeah,
How are you thinking about that?
So we're actually basing our costs on what if you were using arrested anaerobic digestion and selling the volatile fatty acids on the open market, the economics would look like. So that's basically we're imagining that we're trying to show the value above that. So that's the price point we set for our particular product.
Andrew, it's clear there's a lot of science and tech that goes into this. Could you talk a little bit about the proprietary tech and how you're protecting that, and maybe a bit about what the competitive advantage is in that respect?
Yeah, so our technology was initially developed in collaboration with the US Naval Research Lab. So we have a partially exclusive license to the technology. So the patent is broad. It's actually our reactor that you saw, we have the full exclusivity on. And then we have additional IP around each end product that we're focused on. So the retinol, and then we're moving into lubricant spaces and elsewhere that we're also building product-focused IP around as well.
So I know that retinol is your first market opportunity. Can you talk a little bit about why retinol, how big that market size is, and how long it takes you to sort of identify and switch to a new product if you're going to switch from retinol?
Yeah, so retinol is a $500 million-ish dollar market a year. Vitamin A, which is basically the feed and nutrition version of retinol, is about a $2 billion market. We picked this because most retinol today is made from natural gas. So actually during the early stages of the conflict in Ukraine, when Russian natural gas was cut off, like producers in Europe were really struggling from this. And so the cosmetic space is, I think we're at time. The cosmetic space was at really, they're focused on green products more than almost anyone else right now, and we can get a high value for this, and we really want to demonstrate for each product that we're going in on that we have good unit economics. Like we don't want to basically jump to an aviation fuel and then rely on subsidies to get there and then have those dry up and the company fail. We want to basically be really sort of thoughtful in how we build and grow.
Thank you.
Great, thanks.
Thank you, Andrew. And next up, let's welcome Dan Morash, founder of California Safe Soil. And he aims to capture the nutrient value of recovered food. Prior to California Safe Soil, Dan served as the global head of energy and infrastructure at CIT. Let's give it up for Dan.
Okay. Hello, everyone. Thanks for coming today. Just want to talk about our process, which is the issue at hand is that U.S. supermarkets dispose of over 5 million tons a year of high-quality meat and produce, fruits and vegetables. So you can see, here's a picture of someone, and a store associate, culling the produce aisle. And that's because it's perishable and people get picky about what they take out of the produce aisle. And so there's always some that doesn't get picked and that ends up going to waste. And so, and store hygiene obviously is also an important issue, and no one wants to go shopping at a store where you can, out back you can smell the rotting produce in the dumpster. Anyway, and organics disposal costs are high, and we can certainly reduce those costs. And the key is not to let the food go to waste in the first place, and maintain the cold chain. So there are big companies out there like Kroger and Mars and Nestle, all of whom have announced big aggressive goals in terms of reducing their carbon footprint. So keeping food out of the landfill, obviously, in volume is something that is important. So we have a proprietary recovery and enzymatic digestion processing technology. Basically, we recover the food from supermarkets, and then it goes into valuable organic fertilizer and high-quality pet food ingredient finished products. So this is at our plant. You can see the red totes collect the meat, sits in the meat locker in the back of the store. The blue totes collect the fruits and vegetables. So these double-walled insulated totes are able to help maintain the cold chain. And then this is the beginning of our production line. Our plant is SQF qualified, which means that it operates to the same standards as human food production. So we have been selling fertilizers for a number of years. So we got over $4 million a year in sales. It's well suited to regenerative agriculture because it's a liquid and it's a way of getting organic matter into the soil without having to till the soil. And it contributes to carbon footprint because when you improve the health of the soil, the plants respond by growing more roots, taking up more water and fertilizer, are more efficient, and so you can cut your chemical fertilizer use by 15%. We have protected our technology. We've got 41 patents globally and have international licensing opportunities. On the pet food side, this is something is more recent we've been working on. Enzymatic digestion, basically, our technology is the same thing that happens in your stomach. So this is biomimicry. You take long-chain proteins, fats, and carbohydrates and use enzymes to cut them into short-chain amino acids, organic acids, and simple sugars. And it turns out the amino acids and the sugars combine in something called the Maillard reaction, which browns the food, and it makes it taste good. So we kind of stumbled into this. Anyway, we separate the fat from the water-based material, so that's a separate product that's in high demand. And then palatants. Palatants are what is sprayed on the outside of kibble. It turns out that, again, this material is highly palatable and replaces hydrolyzed chicken livers, which are expensive. So there's plenty of room in the economics. And then it can also be included as an ingredient in wet and dry pet food and can be made into treats. These treats at the test kennels tested 4-to-1 in favor over Milk-Bone, which is the market leader. So again, the palatability is there. And you can see on the EPA's curve here, it's right after donation is upcycle, which is to make good food use and to recover the nutrient value of the food, as opposed to anaerobic digestion and composting, which are certainly preferable to landfill, but involve letting the food rot and ferment. So we're upcycled certified, and we reduce the carbon footprint of our customers through their Scope 3. We've had outside parties do LCA, life cycle analysis, that shows we reduce by 4.4 tons per ton of product. So we've gotten a lot of sustainability recognition, and we're looking for supermarkets to partner with because we're expecting significant volumes to come out of the pet food industry. For that matter, we can put white label pet food and home lawn and garden products on your shelves as well. And then, of course, we're always looking for money.
Thank you, Dan. And with that, let's go to our judges.
Dan, really great presentation, and congratulations on the great traction. I'm especially curious about the pet food side of things. It's something that we've thought about before and looked at in the early days and couldn't really figure it out, so congratulations. I'm curious about how the source separation or screening process works to make sure that there aren't any contaminants going into that end product that you're developing. And then part two to that question is whether there's some sort of FDA-like approval process that is required to kind of have your product certified, and whether there's any type of liability that comes with your product maybe having something that isn't wanted in
So
there.
there's the sort line. There are stands on each side of the sort line. There's 2 guys on each side. So if there's any contaminants like a serving spoon or something like in that, they're there to pull that out. Also, we learned that dogs don't like citrus fruit the hard way. And so we cull out all the citrus fruit. They also don't like onions or garlic. So all of that has to be culled out. And so that is how we do that, how we maintain the feedstock is surprisingly consistent. And we also do blending in order to, and then we have controls through lab tests before any batch goes out.
Thank you.
Thank you so much. I also wanted to double click on the pet food new business line. If fertilizer's been so lucrative, why pet food at all? And my second question there is, and I think you said white label, so is the plan to do B2B then for pet food, or are you also intending to launch a B2C brand yourself?
We could launch a B2C brand. We don't really want to do that. We want to have large corporate partners on both sides, the supermarkets at the front end and the pet food companies with the finished product. So, and you know why? I mean, there's 5 million tons of feedstock available. There's no reason to limit fertilizer production or pet food production, but pet food production, what you're selling against, your competition is at a higher price than where it is in the fertilizer market. So that obviously, looking at the competitive analysis drives our margins, and we're price takers in fertilizer, which is unfortunate because the real benefits of feeding microbiology in the soil are tremendous. It's a hard sell.
Dan, I saw that you are source separating meat product from the fresh produce and other inputs. Can you tell us a little bit about how you think about the mixtures of meat and other types of food waste going into what's an optimized end product, whether that's pet food or fertilizer?
Well, for the fertilizer, it all goes in. For the pet food, there's more culling, as we talked about, and you want to have the ability to separate fruits and vegetables, which are vegan, from meat, fruits, and vegetables. It's lower protein level, but still 16% of protein, so, you know, from vegetable protein. So, and some customers want that.
Can you tell me a little bit more about your scale-up plans? I know you said you have a plant right now. Is the idea that you build more of those plants co-locating near big supermarket customers, or are you going to utilize contract manufacturing? Talk to me a little bit about where you go from here.
No, we want to put one of these plants in it's basic infrastructure. We want to put one of these plants in every major metropolitan area in the country. We want to co-locate with the distribution centers of our large supermarket partners, which minimizes logistical costs and maximizes the quality of our feedstock. This is the kind of thing that you can get long-term tax-exempt bond financing for, and throws off enough cash flows to minimize equity dilution.
Do you have the estimate cost for one of these plants?
Yeah, one has been built for $120 million. It could probably, at scale, you know, with repetition, be done at $100 million per copy for 60,000 tons a year of capacity. The capacity is a little bit of a mixed figure. You know, it depends on how many shifts you work. You work 2 shifts, it's one thing. 3 shifts, another. You work the weekend, it's another. So capacity is not a fixed thing.
Dan, when I think about your cost profile in making an end product, there are some costs that stand out to me. You talked about logistics. You certainly have an energy component. There's a labor cost. How would you break down those cost units that go into making an end product? And is there something that you think about when you open a new factory, whether that's a proximity principle where you're collecting the waste, the energy cost within that location? Maybe a little bit about what makes a really good location and facility to kind of create the lowest cost of goods sold possible.
We have a lot of extra ingredients that we input into the fertilizer in order to raise the NPK rating. So inputs are expensive there. But the basic product, which is proteins, fats, and carbohydrates for the animal feed, we don't need much of any inputs. The enzymes we use are not expensive and commercially available. Labor is our largest cost, and when you scale, you get economies of scale in terms of unit labor costs.
Okay. Thank you, Dan. And let's give a round of applause for Dan. And so we are now going to welcome Sue Marshall, and it looks like she's handing out samples. She is the founder and CEO of Net Zero. Sue is also the founding member and emeritus board member of the Upcycled Food Association. Thank you, Sue.
Thank you so much. Happy to be here. I'm going to take you on a little bit of a different journey than we've seen on the past two presenters. So I want you to close your eyes, and I want you to imagine it's 6 o'clock and you're thirsty. What is in that glass that's in your hand? Okay, lots of different things are coming to mind, I guess. One thing that I just gave the judges and Alejandro was apple pieces from a cidery. So that's what we're going to talk about today is not food waste. We're going to talk about food assets or food byproducts and side streams. So Net Zero was actually founded out of a university back in 2015. I had found the technology using infrared used on cow manure. We're not going to talk any more about cow poop, okay? But what it did is it was like a combustion. So if you think of freeze drying, that's kind of what it is. It's instantaneous combustion with infrared. The beauty about infrared is its efficiency in the heat and also a kill step. There isn't pathogens that are going to exist through this. So when I looked at that and said, I want to put that on food, people thought I was crazy. So the first thing I did is I went to all kinds of manufacturing, food and beverage manufacturing, and started looking at the side streams. So what is the problem? When you look in these manufacturing facilities, what do you see? So on the top is what you see. You see them doing stuff, making stuff, and then you see them putting it either in a dumpster and then a truck, or a truck, often semis. Now remember, when I'm going to facilities, I'm seeing thousands of pounds an hour. This is not a little bit, this is tons. And so from there, they do a variety of things. They land apply it. There are reasons why certain states, if you have your windows down when you're driving through them, they smell. There are reasons for that. They also, take it to the landfill, and sometimes they feed animals. So all this is a possibility. It's not consistent. That's what I found out. Depends on the day. So that is the problem. What we want to realize today is all those products have nutrients, protein, fibers, antioxidants. We talked a little bit about vineyard waste in the last session. There's a lot of antioxidants in that. So what is the net zero solution? The net zero solution is actually, you can see it on the bottom there with the little net zero. That is what I call a glorious food-making dumpster. It's actually the size it can sit on this platform. It is meant to be at the end of their line, so they don't have to put it in traditional dumpsters, and they don't have to put it in trucks yet. They put it in our equipment. We do anywhere from 800 to 1,000 pounds an hour, depending on the moisture level. 2/3 of that, give or take, is going to be water. That's instantaneously evaporated, and what comes out, like the judges have in their little envelope there, is a completely dried, up to 90% product. Fruit, veggies, grains, whatever went in, comes out. We don't powder, we don't do anything like that. We just stabilize, capture, and then we convert that to an upcycled food ingredient. From there, it's packaged in super sacks, and then it goes on its way. It could actually go to Andrew, it could actually go to Dan. It can go to anybody who wants to make that human consumption. It can be grinded, it can be powdered, it can be fermented, rehydrated, anything anybody wants. And the beauty about this is it's not our decision on the end use case, it's somebody else who's gonna use that beautiful food for a different purpose. So that is how we get at net zero. We capture that food side stream byproduct and we convert that into upcycled ingredients for human consumption and pet and all other kinds of variety of end uses at scale. So what is the problem with all this? Why is this not a thing? People come up to me and say, if it's so great, then why don't we have all these side streams? Well, we've learned a lot yesterday and today. There are all kinds of reasons. First of all, it's not measured. Unbelievable, but it's really not. And to this date, there isn't a lot. You can't walk into a food manufacturing company and get a straight answer. They actually probably know, they just don't want to know. And then there really isn't any way for them to do it. Okay, Secretary Vilsack had some points today. It's not, to date, has not been an economic viable solution for them to actually turn around and make it a food product that they can sell until net zero came along. So that is what we do, is we take a look, we can do it's agnostic, we can do various byproduct streams from anywhere from 5 cents to 28 cents a pound, all in labor and energy. So that's completely different than what you've seen today, and it's on site, so we don't have to worry about food safety. It's done, and it's ready to go out as food. Another thing is investments. It's really hard. We talked about that earlier, about getting investments throughout the value chain here, and in particular with this byproduct streams, it's really hard to get investments. So that has been a downside of that. Another thing that I'm finding in the upcycled ingredient world is co-packers. So I was on the phone about an hour ago trying to get a super sack full of something up to some co-packer, and they had never heard of upcycled ingredients, okay? So you have this little bit of challenge of trying to educate them. I will tell you, I know of some co-packers actually starting, and they're going to concentrate on upcycled ingredients. So we're seeing some really great trends in that arena. So often, the biggest thing is the word waste. Whenever you use the word waste, you think of an expense. This is actually an asset, so we should stop using the word waste when it comes to byproducts and saying assets and get over that waste, i.e. expense concept. So as far as I'm concerned, the only way this is going to work is to get that ingredient price down. I was mentored by General Mills early on, and they said this is cute, we see the impact, but unless that ingredient is the same price or less to what they're replacing it with, it's not going to work. So that's what we did. We went up and we went after it, and that's what we did today. So competitive advantage, we are not a dryer dehydrator. It takes 24 hours or instantaneous. We have the kill step, and our price point is it's about $489,000, and an ROI with any kind of food manufacturer can be anywhere from 12 to 24 months. And that's it.
Thank you, Sue. And so we're going to hand it now to the judges to assess.
Can you elaborate a little bit on what your revenue model is? Are you selling hardware? Are you licensing the tech?
Yeah, great. So yes, we are right in the middle of negotiations on licensing the IP that has to do with building the equipment. So in our model, it's not just the equipment, it's knowledge, equipment, and connections. Every time you go to a food manufacturer, they get it. They're like, cool, I can actually ROI this given my waste expense, but who buys this stuff again? So they don't want to sell it. So Net Zero is in the business of making those connections to sell the ingredients. The negotiations currently are in actually building the equipment and distributing that globally.
Thanks, Sue. I'm curious about the technology itself and a little bit about the process that's taking place to turn this into edible food again. And maybe on that, talking a little bit about how, versatile the design is, whether it's a one-size-fits-all machine or if you have certain components that you can configure specific to an end user.
Yeah, so we talked a little bit about biomimicry, so I'm going to kind of go there. So you are walking on a beach and you don't have your sandals on and it's 110 degrees. You are running, okay? That sun, that heat from the sun is the same as infrared. That is and it's direct, right? So the way the equipment works is that's applied on the food, very direct, very efficient, and that's a rotating method. Just like the shells and the waves, they go out, they come in, they go out, come in, and the shells turn into sand. It's exactly the same process. So to answer your question, the bolt of that is always the same. Rotational heat, tilt, because some things take longer, so you might go longer. But at the end of the day, it goes in one side, goes through that rotation, and comes out the other side.
So the piece of hardware that's getting built, is each one custom built or using off-the-shelf parts? And we'll start.
Yeah, so our generation 2 currently right now is one size. Okay, so it's about 1,000 pounds an hour, and that's also software driven. So how it's versatile is in the software and how we build the recipe for what's going through it. So that's really the only thing that changes is how that recipe is built in that software. But other than that, it goes in one side, out the other, and we do the recipes. That's part of the IP too. So if it's grain going in versus apple pieces versus other types of fibrous material, we've already known what is going to happen for rotation, heat, and tilt.
So I appreciate that you're controlling the inputs of the waste, and with that, to a degree, you understand what the outputs are. But is there some sort of FDA approval process that now has to take place again to resell food back to the consumer that started as waste?
That's a great question. So on the knowledge side up front for actually looking at the facilities, if I'm inside a facility and it's a certified food safe facility, I'm great. Once that food leaves, and it's then carried somewhere to do this work, that's a different set of certifications. So this is what I explain to people. Those are all expenses that have to add on, because some people say, well, we're going to do it outside in a different facility. You just added costs and certifications.
Do you currently have any paying customers, or can you tell me a little bit more about your traction?
I do, yeah. So we have an operating facility in Minneapolis, St. Paul, Minnesota. So we do actually buy PO. We upcycle, and there's some brands that use our ingredients, mostly eggshells for calcium and lots of grains. So those are easy. In the upcycled world, those are easy. Those are already going into products on market, so those have been easy. And then we have an R&D facility where we currently test various byproduct streams for people as well.
Maybe a little bit about the next 12 months. If there was a cash injection today, where do those dollars go?
Right now, as far as the licensing of the equipment, the build and the distribution, that will be licensing fees coming back to net zero so that we can continue some additional R&D. We are going to be filing additional patents, and that's for thermal heat recovery to add a little bit more to that efficiency. Remember, price per pound on those ingredients. Right now, we feel really good, but we want to get that even better, and that's thermal heat recovery and a couple other tactics that will be in Generation 3.
And what would you recommend I do with this apple?
Oh my gosh, thank you for asking, Jen. So one of the folks that had me do this is a tea company, and we have been upcycling hops and vanilla beans. And so he took that, which is the apples from the cidery, the vanilla pods, the hops, and black tea, and the tea is incredible.
That's pretty cool. I'm curious about the cost model again. Of course, there's a unit cost that is considered up front. Are there any other ingredients that go into it, or is it really just at that point labor and energy that the end user has to consider when factoring for their COGS?
No water, just electricity.
And then the follow on to that is the water that's coming out of the machine potable?
Actually, it's instantaneously evaporated. And we've done botanicals and other things that have alcohol in them, and that it went away as well. We were a little nervous when we first did that because we didn't know how it was going to react, but it is instantaneously and it evaporates.
We have time for one more question, if there is one.
Anybody out there? There's got to be some questions.
Maybe, oh, sorry, was there one?
Yeah, great question. The bulbs are what has like 10-year, depending actually on hours. So the infrared bulbs are really the rest of it is mechanical. It's a big rotational stainless steel drum with a rotary motor on a stand. So that's, pretty much every people that see engineers go, oh, cool, I could even fix this thing. It's just the bulbs, and we have a replacement plan attached to that.
Okay, and so with that, we are going to let the judges deliberate for about, let's say, 8 minutes. But we want to now turn the participation to the audience. So if you have any questions, what we will do is we have all the presenting companies here. I'll hand the mics.
Comments for everybody?
Okay, so pass the mics across. And so if anyone has any questions, maybe, actually I'll hold on to this one, I'll just go around. But if anyone has any questions, please raise your hand and I will direct it. Or you can also come up to the middle stand here. Rupal, first.
Hi, this is for California Safe Soil. I was curious about the feedstock and whether you, just given the location of your facilities in the middle of the Central Valley where there's lots of farming operations, do you pay for that feedstock? Is it contributed to you? Like, how do you negotiate that piece?
It's delivered to us at one price, which is low, or we go and collect it at a higher price, which reflects our collection costs. In both cases, it's less than what the supermarket's paying today.
And is it a centralized? How do the logistics work? Is it centralized? Anyway, do you have to? Is there a logistical nightmare to this? Or
Ideally, the airlines use hub and spoke. A backhaul to the distribution center is always going to be the most efficient way to collect.
Thank you.
Hey
Thank you. Catherine Devine from WWF, also for CSS on the pet food side of things. So having a dog, but then also working with pet companies, there's a huge range of products, right? And also pet food companies are looking to have nutritional adequacy depending on the pet and dietary needs. So how customizable is the pet food solution that you have? Because you had it broken down into 4 categories, but within those and the wet and dry, if Mars were to come to you and say, I'm really interested in ramping this up, how much are you able to customize according to different product lines for pet food companies?
A lot, but the nutritional profile is excellent. It's fruits and vegetables. So it's actually something that they're looking for. And there's, a good component of dietary fiber and so on. So it's, formulation is something that, we're working with a company called BSM Consultants. They have 30 pet food formulation consultants. And so they work their magic.
This is for Sue. What is your product? I mean, you said, is this something that goes to the food processor, manufacturer? You're selling equipment to them?
Yeah, exactly. So the equipment would be on site with them. So as soon as that byproduct comes off the line, it goes right into the equipment. So then what comes out of that is ingredients, like we'd see here in these apple pieces. And from there, then it's sold to other food manufacturers for human and pet food.
So you mentioned like the exquisite tea. Which of those suppliers, manufacturers, is that machinery? You said you combined different products to make that tea.
That came out of my facility, and I get to play, so I have fun.
Do we have samples of that?
I wish. The vanilla was great. I should have brought that for you.
Thank you guys so much for being here today. My name's Alex Katz with Wallamai. 2 questions have been on my mind lately around food upcycling, so feel free to answer both or either and either. One is around, you guys are capturing from groceries, from food manufacturers, but are there some organic food waste producers that you think are not or won't be able to be captured by different upcycling solutions under current practices? So that's the first question. And then the second question is, we just had this great study come out that I'm sure most folks saw around the presence of microplastics in humans. How concerned should we be? How likely are things to be changing, maybe on the regulatory or other stakeholder pushes towards you guys of how handling of microplastics is done in upcycling food waste?
So I'll go first, and then I'll let Dan go, or Andrew, whoever wants to go. When I'm looking at clean streams, so single streams for the most part. When I go into a facility, if they're sometimes they put enzymes or some other product in there to get it through the waste, to get it into a dumpster or centrifuge or something. So I have to coach them into not doing that, get that back to whatever came out is how I want to deal with it. That is a problem because they're doing 10, 15 tons a day or something. So to get them to change how they were trying to push that waste out can be a big deal. But that is a showstopper. I wouldn't be able to do any of that if something not clean is being added.
So I think the biggest challenge with the food waste remains sort of the household municipal waste. It's an education problem, and people are not motivated. And I think really from our perspective, like if you can drive even that to rather than again tipping, if there's like some way to like almost incentivize the putting of these streams for the like Mill is here, you can see their booth. Like if instead of like Mill charging people, like they paid people for every box that got shipped back or something, like if we're at a point where that is, I think you can solve the municipal problem. But other than that, like it's just, that is the hardest one in my view. And for us with the plastics, one of the interesting things about our technology, because we are doing so much processing, our final step is this nanofiltration membrane separation. So our products that are coming out are chemically pure, like 99% pure of a particular molecule. And so we're able to like exclude other things. Like if it's really contaminated, it's gonna mess up the bioreactors, but like small amounts of microplastics, things like that, our system thankfully can probably be pretty robust too.
Yeah, and I guess I would say that food waste is a big problem, which is why everybody is here. And the way to solve a big problem is to break it down into a series of smaller problems that are tractable. So, and I think that's part of what you see here is people attacking different streams of waste in different ways and letting the technology vet. I'd agree with people who've said, you know, the economics have to stand on their own 2 feet, which is certainly our experience. But provided you can check all the boxes, there are definitely willing participants.
So we're going to try to do 2 more questions pretty quickly.
Awesome, thank you so much. Absolutely brilliant solutions. In terms of the carbon impact and carbon footprint, I think you kind of compared it to kind of if this would have ended up in waste streams. Can you maybe talk about the carbon footprint compared to the alternatives, like compared to goats or traditional pet food or traditional kind of digestion?
Just additional question to that is, have you considered carbon credits as part of the revenue stream on all this?
Yeah, I'll go ahead. I get a lot of the carbon credit thing. So yes, we are evaluating how we want to measure. There's a lot of people, some of them which are here who do some of the measurement that I need already, which is if you take a look at just at some certain grain, let's take a look at Kernza grain, if anyone knows what that is. So they're starting to use Kernza in whiskey. Kernza is a sustainable regenerative agriculture grain. It heals the soil. So that, if I can get a distillery to use that and then I upcycle, the carbon credits should be higher because of the grain used. So in my world, I always take a look at what is the inputs. Are they, how do they compare before I even get them? And then when I add what I add to it, how is that better than growing grain again? But there's a lot of ways to measure this, and I'm really interested in, and also AI too, and how that when we do these recipes, how we can use AI to make them even more efficient over time too as well.
So I think like the comparing is really important. I think actually ReFed is working on some really cool tools for doing that. But I think one of the things that we don't have a really robust LCA for our particular technology yet. And one of the problems I see with all of this stuff is, particularly in the food waste space, LCAs need to be done very intelligently. So like a really crude LCA for our technology would show that if our process was really inefficient, we would be capturing more carbon because we'd be using more food waste. And that's really dumb. And so like you have to think carefully about how this LCA is being built and doing this in the right way. So that's my 2 cents on that topic.
There's a budding cottage industry in third-party LCA studies. So we've had one done by SCS Global and another done by Planet Forward, and they both came back with the same results. So we thought that that was probably a good indication. As to monetizing that as carbon credits, that doesn't happen. But the big consumer products companies who've all made commitments to this have come to the realization that it's going to be in scope 3 that they're going to get their carbon reductions, and that's supplies. So you get a customer is what you get.
Okay, so thank you. I think that is it for Q&A, and our judges have returned. And so I will pass it off to them to hear what they've decided.
All right, well, first of all, we enjoyed all 3 presentations and really excited to see how you guys scale. I think you're each approaching it with a really unique approach to different technology, and hopefully you can help solve some of the waste valorization issues that I know our investors are always looking for waste valorization solutions. So kudos to tackling that challenge. In terms of choosing a winner today, it was a very difficult decision, but we have decided, actually I'll let you announce and then I'll tell why so you can.
Congratulations, Sue from Net Zero.
Yeah. Yes. Congratulations. We were really taken with how novel the tech piece was. Neither of us had seen anything like that before, so really has a clear differentiator there. Also that it was on site within the facility, and we liked we like the certification answer that you gave as well. I think the places that we'd love to see you continue to work on would be related to the business model. I think that still felt a little unclear and always a little scary to hear about scaling up selling hardware, as well as proving out the concept of being the person to help with sort of the off-take piece as well. And
Just continue to think about the unit economics and the costs that go with the end user's adoption of that tech.
yeah. And the energy piece was still a question we had. I know with dehydration technologies that can sometimes mitigate a lot of the positive impacts of doing the upcycling. I'm not as familiar with your technology to fully understand that, but that would be something we'd want to look into and understand as well. But great job, and congratulations to all of these amazing startup founders, and thank you all for coming.
And we have some other notes too. Yes, we're congratulating the founders, but I also want to give a big thank you to our judges up here today. And so after the session, there is going to be a main stage session, which is going to be leaning into business solutions in the ballroom. So be sure to go to that, as well as engage the exhibitors that are going to be outside. Thank you, everybody, for joining, and have a wonderful day.